My preview's not working. Hang on. Okay. Much better. It's fine. Okay. My back is a bit sore from deadlifts. I can feel. It's been like, I don't know, a year since I did deadlifts. It's cooked. My back. It's good. Not doing them for another year though. Okay. I don't know how, but I totally forgot about this other display that I had. You can see, yeah, it's a bit better, I think. Hopefully it works. The whole display works. The only difference is that it's a bit stubbier than the other one. The other one was longer, so I'm gonna try. But the good thing is that is the good news. It's the same driver, so I should be able to just plug it in and it should work. And I also, in the same box, I have to say, I found this board. It's a bit more nicer. Like, it's the same thing. It's still a Raspberry Pi. But it's got like these pins to like connect peripherals easier. Peripherals, like not peripherals, like sensors. Like for instance, this Wi-Fi thingy gets connected straight onto it. Pretty neat. It's got like 6 cables. And I don't know what each of them do. Yeah. So I want to try running the display on this thing, see if it works. Excuse me. And then gonna look into this Wi-Fi device. What is it called? Wi-Fi microcontroller. Yeah, that. See if I can connect the display. Go around. Seeing a challenge already. is, don't know which pins it connects to. Okay. Going either way. Okay, they're only going one way. Okay, pretty good. Pretty snug. Nope. Okay. Now, which pin are you connected to? It's even got a speaker. Nice. It's got a physical mute button. Pretty cool. Right, okay. Okay, oh, I see it here. GP0, GPIO1. That should be... It's CLSDA. Just double check. Okay. Raspberry Eco. What was it called? Pin? Yeah. There. So GPIO 0 is SDA. And that's the white wire. And it is, yeah, first time. Right, okay, yeah. Seems to be connected to the right place. So, if I, oopsie. Okay. I need a better connection situation. It's a bit crowded on the left here. I do have this dongle, but it's got the tiniest cable. Okay, never mind. So this one had an on-off switch. Okay, it doesn't. Right, okay, let's connect this. Oh, damn. It's got lights. I like lights. See? Hey Zion, 19. How you doing? I'm just trying out a new board. Okay, this should turn the display on. Nice. It still works. Okay. Hey Zion. I'll give you a bit of a catch up. I don't know if you've ever been here. So I'm working on a side project. I never really worked on embedded stuff before, so I decided to build this small project that connects to my Wi-Fi, and on that small display it tells me like what DNS I've been looking up. Or it could just be websites that I've been looking up, and just lets me know like how I use my time. And yeah, it's a simple project, but I've made it a bit too complicated. Not too. Excuse me. Yeah, so I've started off by writing a display driver. I don't know if I can show it to you. Like to get stuff showing up on the display. And I mean, it only took about 10 days, but hey Sha baby, how you doing? I found a new board in the box, so just trying that out. And I've also, it's hard to show you, it's got this is the Wi-Fi microcontroller. So yeah, I'm going to be looking into, it's a lot of wires, looking into like writing a driver for that one next. Yeah, that's it, I guess, for now. How you doing? It's a bit flimsy. Hey, so the code still works, and I mean it worked. I was quite surprised to get it on the first try, but I might have to make some updates. Okay, so this is the next step. I gotta write a driver for this one. This one looks a lot more complicated than the display. Okay. ESP8266 datasheet. Provides tool performance evaluation tools. Think. All right, yeah. Let's try that one. No, why is it a PDF? Yeah. See if I can find a web page. It's a low-cost Wi-Fi microcontroller, built-in networking, and microcontroller capability. And the chip was blah blah. Dual AI thinker. One module allows microcontrollers to connect Wi-Fi network and make simple TCP/IP connections using Hayes-style commands. However, At first, there was almost no English language documentation. Similar chip built with 1 MB flash memory. One MB. Oh, it's quite big compared to the display, which is 512 bytes. Yeah, not even kilobytes. Not even 1 kilobyte. ESP32 family of devices. Okay. I want to see ground. Input number 0. Receive data. Actually, I just realized now that the display is working, I can use it to debug the other sensors. Interesting. Data. SDKs. ESP8266. MicroZig. Nothing. Data sheet. Okay. That's not bad. It's only 30 pages. Is this the right one? No, it's 86. Oh, no, it's correct. What's the EX? Not sure if I... $82.66. Not sure what that EX is for. Let me ask chat. Is there a difference between the ESP6 and the ESP8266EX? Okay. What's the difference? Well, doesn't... That is... Ah, it is right, actually. It says ES... So, it's fucking tiny. ESP... Okay. Damn. 82... Yeah, it does say ESP8266EX. Yeah. Suppose this is fine. Okay. So I think this is the data sheet. That was quick. Thought it might have been harder. Damn. Transmitter, receiver. Oh, it's got an I2C interface. I didn't see it on the board. Yeah, I will look at it later. It's not too bad. What is this? Must read documents. User guide, pin list, getting started. Do I need the SDK? I'll come back to that. Okay. This is not going to be very entertained, I would say. Hang on, I'll be right back. I'm gonna get some coffee as well. Okay. Right. Oh, the mic's a bit too sensitive. Or like not sensitive enough. Right. Okay. Same. Yeah, the ESP drivers delivers highly integrated Wi-Fi SoC solution to meet users, blah blah blah, with the complete Wi-Fi networking capabilities. Standalone application. Yeah, that's the bit. Because as far as I understand, I think it's also a microcontroller. The ESP. Oh no, there was an ESP32. Never mind. But okay. When oh, the ESP, I'm gonna call it the ESP, hosts the application, it prompts boots up from the flash. The integrated cache, blah blah blah, can be applied. The ESP can be applied to any microcontroller designed as a Wi-Fi adapter through SPI, SDIO, or UART interfaces. Okay. What about I2C? The ESP integrates antenna switches, RF, whatever that is, RF balloon, balun. I don't know that. What is that? What is RF balloon? Balance to unbalance is two-port component that converts an unbalanced RF signal to a balanced. Okay. Interesting. Not sure what that is, but interesting. Power amplifier, low noise receive amplifier, filters, and power management modules. The compact design minimizes the PCB size, blah blah blah. Besides Wi-Fi functionalities, series 32-bit, yeah, okay. Sensors through the GPIOs. What do you mean? I don't see any GPIO. Not sure what that means. The SDK provides sample codes for various applications. What if I don't want to use the SDK? How big is the SDK? ESP8266 SDK. RTOS. What is RTOS? Release branch. Okay, let's have a look. Make tools docs. Components. Damn. It supports MQTT. Oh yeah, well, IoT devices. Wi-Fi provisioning. There's a load of files in here. Don't know how much of it I can. Let's have a look at one. Maybe provisioning. I don't care about pro. Is it proto as in protobuf? Nah, don't want protobuf. Source handlers, managers, config, scan. Let's have a look at this. Okay, that's just a scan for Wi-Fi. Scan status. Scan start. Okay. What's age? Is that whatever that is? Okay. How do you actually command scan start? Where's this command? Request. What is request? What is, yeah. ESP. Okay. Where's this method? Oh, okay. You gotta call it Wi-Fi scan payload. Where is that defined? Here. Wi-Fi scan payload. Yeah. It's defined here. Okay. Put above, see message, Wi-Fi scan message type, status, payload. Command start, response, scan start, status, scan status. Okay. I don't know what all of that means, but let's come back to that later. Various applications, blah blah blah. Smart connectivity platform. No thanks. I am interested in whatever that is. Make a mental note of that. Come back to that later. Wi-Fi key features. Okay, that looks good. 72. Good. 2 virtual Wi-Fi interface. Not sure what that means. Automatic beacon monitoring. What's that? TSF. Beacon monitoring. Timing synchronization function. What is beacon? Okay, I think it's a good question for chat. What is, okay, yes. found this in the data sheet for ESP8266. What does beacon monitor mean? Oh, access points. That's what AP stands for. I think I saw it a few times. Is it here? No. Access points periodically broadcast special management frames called beacon frames. Access points. Access points. Okay. These beacon announce the presence of the network, specify its capabilities, and contain a timestamp. Okay. That's a beacon frame. Timing synchronization device. Okay. TSF keeps all devices synchronized. Okay. Makes sense. The AP includes. Okay. So I'm guessing the ESP is an access point. Maybe. Okay. Okay. No. So this would be my Wi-Fi router. Okay. So the ESP listens for these beacons and adjusts their own internal TSF. This keeps everyone's clocks aligned. Okay. Beacon monitoring. What was my question? Okay, yeah, this was it. This is simply the process of Wi-Fi client listening and receiving these beacon frames from the AP it is associated with. Okay. Hardware TSF. This means TSF timer and the logic to update it based on received beacons. Okay. Are implemented directly in there. Okay, so it's implemented at the hardware level. That's good. I don't know how to do it myself. Okay. Right. I know what automatic means. Okay, going back. Support infrastructure, BSS station mode, soft AP promiscuous mode. Interesting. Specifications. Think we can skip over this. Oh. Operating temperature. Voltage. I think it's 3.3. Should be fine. Is that an LED? Yeah, that is. It's not on. So I'm guessing no driver at this point. Frequency range 2.4 to 2.5. Okay. It's got a 32-bit processor. Okay. Hmm. Oh, okay. This is the software. Okay. I was wondering. Sounds a bit weird that the hardware supports TCP and HTTP. So I thought they were like at the software level, and it is. So I wonder if it has its own software on the chip. Let's see. Yep. ID tags. Really? Wi-Fi position system beacons. Pin definitions. It's a lot of pins. Just gonna go over it. IO, blah blah blah. Okay, never mind. Functional description. Okay. Integrates with this processor. RISC processor. Achieves blah blah. Maximum clock cycle. Oh, so that's what RTOS means. Real-time operating system. Allow 80% of the processing power to be available for user application, programming, and development. CPU includes the interfaces as below. Programmable RAM, data RAM, AHB interface. Okay, only if I need to go in there for now. Wi-Fi SoC integrates controller and memory units including SRAM, ROM, MCU can blah 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 blah. It's fine. And in sequence, blah blah blah. According to our current version of SDK, SRAM space available for users. RAM size less than 50 KB. When it's working under station mode and connects to the router. Station mode. The maximum programmable space accessible in heap plus data section, around 50 KB. There's no programmable ROM in SoC. Okay. Hmm. Yeah, I think the program will be on the Raspberry Pi, so that's fine. External flash. SPI mode supported. Standard SPI dual quad. The correct SPI mode should be selected when flashing bin files too. Otherwise, the firmware won't be working. Okay. Clock. I don't think I need to worry about it too much. I'm using the I2C. Receiver, transmitter, yeah. Channel frequencies. The transceiver supports the following channels. Channel number 8, frequency is that. Oh, okay. So it supports 1, 2, 3, 8, 9, 10. Oh, no, there's more. Okay. 1 through 14, and there's a few frequencies. Don't know what these channel mean. Channel. The RF receiver. Transceiver. What's that mean? Which is combination of radio transmit. Okay. Can transmit and receive. Makes sense. Goes from 2412 to 2484. Okay, I mean, well, I think it might be useful later. The receiver. The 2.4 gigahertz receiver downconverts the RF signal to quadrature baseband signals. What does that mean? Quadrature baseband signals. Two amplitude modulated components. Okay. In phase and a quadrature component that's 90-degree out of phase. Okay. Where's the 90-degree? Oh, that's cool. Damn. Haven't looked at sine and cosine for maybe 15 years. That's crazy. Okay. I don't know what that is, but do I want to know? Maybe a little bit. Okay. The 24.4 receiver downconverts the RF signals to quadrature baseband signals and converts them to the digital domain with two high-speed resolution ADCs. To adapt to varying signal channel conditions, RF filters, automatic gain control, DC offset cancellation circuits, and baseband filters are integrated. I think I'm gonna ask the AI, what does this mean? Can you explain this sentence to me? Yeah, okay. The receiver. Yeah, that's the device. That part I understood. Down converts the RF signal. That one, not so much. These are the radio frequency waves. Okay. Yeah. They oscillate at around 2.4 billion times per second. Right. By oscillate, I mean they go up and down. Yeah. I guess. Yeah. Maybe let me just look up oscillate. Swing back and forth at a regular speed. Okay. They could be sideways as well. I think it's irrelevant, I'm guessing. Down converts. Processing signals directly at such high frequencies complex and power intensive. Yes, okay. Down conversion is the process of using mixers type of electronic circuit to lower the frequency of the incoming signal to a much more manageable range while preserving the information. Interesting. That makes it faster? Maybe. Let's find out. To quadrature baseband signals. Okay, what is a baseband signal? These are signals whose frequency spectrum is centered around 0 Hz or a very low intermediate frequency. Centered around 0 Hz. I mean, these are signals whose frequency spectrum. Range of electromagnetic waves. Okay. This is the wavy thing, I'm guessing. Centered around 0 Hz. So it's barely oscillating. Okay. This is the result of the down conversion. Okay, so it's brought down from 2.4 to nearly 0. What does it mean, centered around 0? Where is it? Frequency spectrum centered around 0. Oh, okay. No, now I understand. So I'm guessing, okay. No, okay, I got it. That means the center is around 0. It could go up or down how much ever. So I don't know how much it down converts it to. The so where is that one centered. 0.4 gigahertz frequency center. Is that it? Oh, yeah, I'll ask it later. No, I won't ask it now. So the signal source frequency. This is the result of the down conversion. Open your chat. So in the original 2.4 gigahertz signal, how is the frequency C centered? Yeah. To be fair, I don't know what it means when it's, what does centered mean? What does centered mean? Okay, imagine you're looking at a graph where the horizontal axis represents frequency. Yeah. The vertical axis represents, yeah, the strength. Okay. Signal, especially one carrying information, doesn't exist at just one frequency. It occupies a range of frequencies. Okay. When we say a signal is centered around a particular frequency, it means the midpoint. The frequency is the approximate middle point of the range of frequencies the signal occupies. Peak power. Usually the signal's power is strongest or very close to the center frequency and decreases as you move away from it or towards the edges of its bandwidth. Decreases as you move away from it. Yeah. Think of, yeah, peak of a hill. Oh, okay. So if it goes this, it's the top. Okay. I was thinking of something totally different. I was thinking of that line in between. So, okay. Centered around 2.43. Oh, think that makes sense. Channel 6, roughly the center. Interesting. If a Wi-Fi uses a 20 megahertz bandwidth on channel 6, 2.427 and 2.447. Yeah, because there's 20 megahertz difference. Ah, okay. Hey, this is kind of fun. 0 hertz. After down conversion, the same Wi-Fi signal might be shifted so its frequency can now exist between, okay, so it's tiny, -10 to +10, for example. Got it. And did it say 0 megahertz? Where did it go? Yeah. Oh, okay. I don't know why even. Here. I forgot why I had that question. 0 hertz. Okay. And the same information is available. It's a crucial technique in modern radio. Instead of down converting to a single baseband signal, the receiver creates two baseband signals from the original RF signal. These are called in phase and the quadrature component. Okay. Damn. I read it, but I have no idea what I've just read. Let's try again. Instead of down converting to a single baseband signal, okay, the receiver creates two baseband signals from the original signal. Okay. Oh, okay, now I get it. These are called in phase and the quadrature. Okay, that makes sense. The quadrature is 90 degrees out of phase with the I signal. 90-degree out of phase. That means when one of them is at 0, the other one is at 90, and vice versa. Okay, genius, yeah. Example, in phase and quadrature. Okay, the blue one is the I, the red one is the Q. Okay. No, I was totally wrong. Because I was thinking, you know, in terms of geometry and not like sine or cosine waves. I couldn't have been more wrong. Okay. Anyway, so guessing it's the same. Let's say it's like sine of something. One of them is like 90 degree less than the other one. Or less or more. I don't know if it can be both. Not sure. The Q signal is out of phase. Out of phase. What does that mean? Physics. Having. Oh, beautiful. I understand now. The peak of one falls into the trough of another. Okay. So as one is peaking, the other one is at the bottom. Ah, okay. That makes sense. So they're like opposites. They don't need to be though. I have a feeling I'm getting way too sidetracked. I'm kind of liking it. Both I and Q allows the receiver to fully represent both the amplitude and the phase of the original high frequency signal. This is essential for decoding complex modulation schemes used in Wi-Fi. I think this part I understand. This was just this bit. I still don't understand what exactly happens. Maybe let me find out a little bit. Sinusoid with modulation can be decomposed or synthesized from two amplitude modulated Gs. It's a great start. I got cheap US. It's back. Get rid of that. There we go. Okay, thank you, Savage Chilix, but no thank you. Right. Chat keeps sinking. Okay, I'm not sure I want to read this right now. To be fair, I was pretty good at trigonometry and not so much at calculus. No, that's wrong. I was good, but then I stopped practicing. Then I got really bad. Okay, let's go back on track. Where was I? Here. Okay. Okay, so now I have some idea. The receiver, so the Wi-Fi signal that comes in, it's converted down to the Q signal and signals and just the Qs. Down converts the RF signal to quadrature baseband signals and okay, but I think it's the I and the Q, I guess. And converts them to the digital domain with two high resolution, high speed ADCs. What is an ADC? Maybe they mentioned it somewhere. I'll look it up later. Otherwise, I'm never gonna get. Hey, I'm already halfway. How big is this document? It's not that big. Okay. What did I just go through? Oh, okay. That's not bad. To adapt to varying signal channel conditions. RF filters, automatic gain control, DC offset cancellation circuits, and baseband. Can I zoom in a bit? Yeah. Much better. Where did I? Yeah, here. Are integrated Okay. Auto filters, gain control, DC offset cancellation circuits, and baseband filters are all integrated. Okay, so that's the receiver. The transmitter. Don't really care much about the transmitter, do we? Oh, we'll just read it anyways. Up converts the... Okay, yeah, do the opposite. And drives the antenna with high power CMOS power amplifier. I've heard that. I've read that before somewhere. Not sure what that is. The function of digital calibration. Further improves the linearity of the power amplifier, enabling state-of-the-art performance. It looks like good performance. Transaction power of, looks like a big number. And plus 18. Okay, all looks good. Additional, oh, my back. Additional calibrations are integrated to offset any imperfections of the radio. Carrier leakage, IQ phase matching, baseband non-linearities. Okay, it just means we don't need any test equipment. Brilliant. Let's go. Clock generator. Generates a quadrature of 2.4 gigahertz. Clock signals for the receiver and transmitter. Right. All components of the clock generator are integrated into the chip, including all of these. Built-in calibration and self-tests. Okay, looks pretty good. It sounds pretty interesting, to be fair. Like this bit here. Quadrature clock phases and phase noise are optimized on chip with patented calibration algorithms. I mean, this algorithm sounds pretty cool. Anywho, and yeah, okay. Wi-Fi. MAC protocol supports basic service set, SDA, soft AP. Not sure what any of these mean. Blah blah blah. Distributed control function. Power management is handled with minimum host interaction. Wi-Fi and radio baseband. Anything in particular? Station mode, blah 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 blah. Damn, I didn't know that. Dual and single antenna Bluetooth coexistence support with optional simultaneous receive. Hey, Miss Me. Oh, sorry, that's a difficult name. Mikosko. Okay, I think I got that right. For which OS or kernel are you writing the driver for? Good question. I don't know if I need to write the driver. I want to integrate this ESP8266 in with my Raspberry Pi Pico. ESP SoC. To be honest, I don't know what any of those words mean because I just started doing embedded maybe 2 weeks ago. Yeah. OS or kernel are you writing the driver for? Okay, yeah. To be fair, I don't know if I even need to write a driver for this one because it comes with an SDK. So I don't know. So I'm just going through the data sheet to see if there's anything. Yeah, if it needs anything. I don't know if that answers your question. ESP SoC. Do you have any kind of dev board with ESP SoC? Not sure what that means. I'm using the Pico. Yeah, and I think it was just yesterday I finished writing my display driver, and I used it's for the Raspberry Pi Pico using the I2C, and now I'm moving on to the Wi-Fi. I don't know, does that answer your question? I don't think so, but yeah. Power management. Okay. Are you into embedded programming as well? I'm guessing yes, because from your question. Power management. Blah blah blah. And yeah, and well, to be fair, Mikosko, sorry. I guess, I mean, you don't know what I'm doing. So just to give like a quick summary, I've never done embedded before, so I was like, I should build something to get, to get a better idea, because usually I work on the web side of things. So yeah, I'm making a simple project that connects, that helps the, what's it called? Yeah, I want to connect to my Wi-Fi router, and I just want to display how much time I spend on websites, but do it through the Wi-Fi chip and the Raspberry Pi, and that's why I connected the display. So I can show you, like it shows. The idea is that like on the display I can see like how much time I spend on certain websites. That makes sense. I mean, you don't need to use embedded. It's just it's just a curiosity project, and the idea is every time, for certain websites, when there's a DNS lookup, I can maybe use the Wi-Fi chip on something like that. I don't know exactly how to do it, but that's the rough idea. If that makes sense. Oh, nice. Qualcomm chips for a company that manufactures Wi-Fi bridges. What is a Wi-Fi bridge? Bridge. Ah, okay. Yeah, I've seen these. Okay, see what you mean. Cool. And do you write the software for it? Okay. You know, in web. Oh, not that bridge. Okay. Hang on. But you know, in the web world, backend means something totally different. So I don't know what it means in embedded development. More backend embedded development. So do you mean you work on the chips themselves? Guess I could look it up. Not the bridges. Qualcomm chips. Qualcomm. Oh, these are the guys who make phone chips. Ah, okay. Now I see. Okay, so you work. Okay, that makes sense. Yeah. Many devices. Okay, that sounds cool. The work on this device. Ah, okay. Ubiquiti U7. I mean, I can Google it. Not sure what that is, but oh, okay. I think I know what that is. Looks like a server. Yeah, it's pretty cool. Okay, so that's not the one. I'm not sure. You gotta ask them, I guess. So, the web services that run on the device, like what language do you use? Okay, nice. I think you're the First person who I heard from who writes Rust professionally. Some of my friends write Rust, but it's like mostly for hobby. That's cool. Nice. I'm currently using Zig to, what's it called? Started using it a couple of years ago. Okay, nice. And okay, so the web service is on the device itself, guessing. That's nice. Cool. Yeah, to be honest, I'm like a bit bored with doing web stuff for like 4 years, so I've been trying different things in my spare time. Yeah. So I thought I'll try embedded. I mean, so far I like it. To be fair, it's only been 2 weeks, so it's maybe it's a bit early. Okay, now I'm a bit lazy. Probably continue from here tomorrow. Peripheral interface. Okay, I'll read this tomorrow. Hey Mikosko, thank you for chatting with me. I think I'm gonna call it a day. And I'll probably be back here tomorrow if you want. And yeah. And I guess have a good one. I'll see you. What's today? Tuesday. Yeah. I'll see you tomorrow. See you, mate.